Hi everyone, and welcome to this podcast. Today we are going to be discussing with my friends Christian and Damien, NAC and the Internet of Things. Now, granted it sounds like a manga cartoon, but I'm reliably informed that this actually is something to do with networking.
For someone who's been a network engineer for a long time, oh God, you just hate having to manage NAC devices. It manages what networks you have access to.
I think it's also important to understand that NAC is basically the only way to protect your physical network ports, because when you are in your company environment, you have two options. Option one is you always have to call your IT to patch a network socket and then have it connected. Or the other option is to leave it open so people can use it when they have to move around in the company. But the problem then is when you have every socket patched all the time, everybody can just plug in and be in your network. And to really protect against that scenario, you have to put in some kind of network access control.
So Damien, can you please tell us what NAC and the Internet of Things are?
I'll start with the easy one, which is the Internet of Things, which is just a very strange phrase altogether, isn't it? And people often abbreviate by calling them things as well, which is even more bizarre. But all it really means is there are certain devices that can be in your home or your office or your work environment that connect to the internet, and typically in the past they might not have done. So, for example, if you have a temperature sensor, normally it would just record the temperature. But what now happens is your temperature sensor will have a little connection to a network that then sends the data it's collecting to the internet, where the temperature data can be recorded over a longer period of time and can be analyzed. So that's a typical Internet of Things device.
And we all have these, don't we? So for example, I've got a thermostat from a company who sells thermostats for doing my heating, and it allows me to control my heating from outside the house. And I've got a cooker that tells me when my timer's gone by beeping on my phone, that sort of stuff. And so all of those things are essentially Internet of Things devices.
Yeah, that's right. It can include very small devices, just like temperature sensors or the sort of probes that we've got, or it can be more sophisticated things like feed from CCTV cameras. Some of the more sophisticated CCTV cameras now, the feed is not, the entire feed isn't sent to the internet, but usually abstract a certain number of frames to send, or they have clever intelligence, AI intelligence, that will identify when something of interest is happening, and then it will suddenly send that data to the cloud, to the internet for further analysis. So it can do things like, it's just bizarre, things like in a supermarket, it can recognize the fact that somebody has accidentally knocked a bottle of vinegar and it's broken and flooded the floor with vinegar, and it can identify that's happening. It can now send that off somewhere. It can then send another message to the store manager to alert the maintenance team to go to aisle 17 because that idiot Damien has broken yet another bottle of vinegar. So this is
nice.
This is connected.
Wow, I was just going to say, and you can get another reprimand on your records, that sort of
I'm banned
stuff.
from so many supermarkets, but let's not.
I'm going to say, Christian, you're into home automation, aren't you? We've had this conversation in the past. So does this mean that your entire house is one big Internet of Things?
I looked at the network not too long ago to show my network management stuff to somebody, and I was shocked again how many devices are there nowadays. Talking to each other and to services, and it's a lot. It's a lot, and I think most of the homes nowadays have something. Even I think 2 days ago I was in a construction market, home market. I don't know what's warehouse, something, where I heard somebody say to his or to her husband, "Hey, we should get that fan because you can control it with Alexa." So people are really now taking more and more things into their homes, not even thinking about that. It's just it's easier to do, and I think many people at home don't really think about it. In the industry, people think about it way different.
Maybe, like I say, I suppose there's the other thing that confused me a little bit about the Internet of Things is there a difference between an Internet of Things device and a computer? So to give you an example, I've got a PlayStation. Now, a PlayStation is literally a computer from the point of view that it's got a full-blown processor, it's got RAM, it's got video cards and various elements. So is that an Internet of Things device in the same way that my thermostat is an Internet of Things device? They both talk to the internet. They both send me notifications on my phone to say, oh, someone just came online or whatever it turns out to be. But I don't think of my PlayStation as being an Internet of Things device. So is there a definition difference between the two?
Gosh, that's a good question, isn't it?
Any ideas?
I think your PlayStation probably isn't, because I think almost by definition, Internet of Things are usually seen as quite simple things that have one function. I think that's probably what I would use as the definition to distinguish. Or you can.
Well, mine's got one function as well. I play Call of Duty and nothing else. So that's pretty much
it. So. Yeah, I think what you can also add to Damien's idea is it's one function, and there's normally no direct way to change the function of it.
Right, okay. So
I think that there are some devices which obviously you can put in new firmware or something like that, still considered Internet of Things devices. But normally you don't change the firmware or the function of your thermostat to be a rice cooker suddenly or something like that.
To be honest with you, I can imagine that being an interesting project. Connect it to a kettle.
Just have to have enough heat.
Yes, exactly. Yeah, understood. Okay, that makes sense. Right, so sorry, we've digressed from explaining what Internet of Things is. So what's NAC, Damien?
So NAC is Network Access Control. Now, for someone who's been a network engineer for a long time, oh God, you just hate having to manage NAC devices. So what a NAC device does, either on a Wi-Fi network or a wired network with good old Ethernet cables, is it manages what networks you have access to. So usually within, let's say, an average office, you might have kind of a corporate network that's there for people who are doing business. Then you might have a separate network that's for the finance people, to kind of keep their work separate from each other. You might have a guest Wi-Fi that's separate. You might have a different network for other devices and things. So all the different networks.
Backup network. They're quite common these days. Obviously, we've been through those.
So now, what network access control does is it manages which of those networks you have access to. So it's not about like a firewall where everything goes to the firewall and then the firewall will either allow or not allow packets going to certain places. Network access control just simply assigns you to that network. So, for example, if you're a simple thing like guest Wi-Fi, so network access control would say when you're on the guest Wi-Fi, you only have access to that single guest Wi-Fi network, and the only kind of gateway you can see is the firewall. And some of the more restricted ones even don't allow devices on the same network to talk to each other. So perhaps not in a guest Wi-Fi, but say if you're on some corporate Wi-Fis, for example, you can say you're on the Wi-Fi. The only thing you can talk to is the firewall. So it's like super secure. So that's kind of what network access control is about. It usually determines the network you're allowed to access, and it's often based on things like it can be linked to the characteristic of your laptop or your device. It can be linked to your login credentials. So, for example, what's common on Wi-Fi is you can choose a particular network to join, and then depending on whether you input the right code or what the certificate is on your device that will authenticate you, the authentication then directs you to the appropriate network as well, or fails you over. So, for example, say if you have antivirus on your laptop, what it will do is it will check the status of your antivirus, and if it's all up to date and everything's working fine, it will let you into the corporate network. If it discovers that no, actually you've not updated your antivirus, it's out of date, you need to go and fix it. But until you've fixed it, all I'm going to do is flip you over onto kind of a fail-safe network, which gives you very limited access.
So essentially, I mean, previously you would maybe have different networks for things, literally different networks, different subnets. So you'd have a subnet for your backups, you'd have a subnet for your printers, you'd have a subnet for your users, and maybe that would be split into offices or floors of the building. But what we're saying here is the fact that these are all maybe part of the same subnet, the same IP address ranges, but but you're using metadata or other data related to those users to define what they can see within that network.
No, you usually push onto one subnet. So, for example, the Wi-Fi thing it would be a discrete, separate subnet. It's a definite IP range.
Right. Okay.
Yes, and that's really how it manages it, is by putting on a different IP range. The only thing I'm saying is within that you can get extra security, whereby even they're on the same subnet, it can still stop you speaking to other devices on the same subnet. But at its simplest, it goes based on your ID. It will put you into a specific subnet.
And this is a feature of a conventional switch, or is this a separate device that you put on the network to be able to just manage this element?
It's an application that usually runs on some kind of server hardware, typically, or in the cloud, that manages it for you. But it speaks to your switches. It uses different protocols to say to your switch, this port has. I now recognise that this person has connected to this port on you, Mr. Switch. Now, what I want you to do is assign that switch port to VLAN 101 or whatever it is. So they communicate from the NAC control center to the switch to define the VLAN, the subnet, the little IP address space that user has access to.
I think it's also important to understand that NAC is basically the only administration-friendly way to protect your physical network ports, because when you are in your company environment, you have two options. Option one is you always have to call your IT to patch a network socket and then have it connected. Or the other option is to leave it open so people can use it when they have to move around in the company. But the problem then is when you have every socket patched all the time, everybody can just plug in and be in your network. And to really protect against that scenario, you have to put in some kind of network access control, which then checks in the moment that you plug in, do you have the right certificate on your device? And then, as Damien said, your controller, be it in the cloud or local, whatever, checks, oh, yeah, it's Damon's PC. It's okay. He can get the VLAN for office network. And if I plug in with my device, which might be just some kind of external, not managed thing, then I would only get the guest network access, which is just talking to the firewall, all on the same network socket without anybody having to switch anything around, any cables or what.
So this is relating to our previous podcasts. This is akin to the plumber, isn't it? Really, to a certain extent.
Yeah, I was thinking how I can bring him.
We need to bring in the plumber. On our previous podcast, we talked about firewalls, whereby conventional firewalls were. Or standard firewalls essentially were you would just identify the plumber maybe by his hair color, or you'd ring his company up and then you'd let him in and you'd let him walk around your house because he's been identified. That would be it. But with next generation firewalls, you would essentially follow the plumber around the house, checking everything he did was plumbing. But it's the same with the social engineering things. If you let somebody into your building and they happen to have an electronic device with a network cable, they can just plug into a port inside your building and gain access to your network. But with NAC, they can't, is what we're saying.
Yeah, they can only see the way out again. And when they identify as the correct plumber, then they only see the room they have really to do work in, and nothing else of your house. Basically, that's right.
So, the way it links into Internet of Things is that's one of the main reasons why people are paying a little bit more attention to it now, because, as you say, people can just plug things into a wall socket. And the proliferation, especially in some industries, of IoT devices is just enormous. There are thousands. They're expected worldwide to be billions of IoT devices spread out. And again, if they're wired devices, that if somebody can plug a different device into that switch port, then they have access to that network, and it can be a huge security risk. And part of the reason for that is when we talked earlier about what is like the definition of an Internet of Thing, most of them are, perhaps my best definition is they're stupid devices. And so you can very easily hack an IoT device.
Okay. Insulting to Internet of Things devices.
They're just stupid things.
They're just thick. They're just thick. They don't deserve to be on my network. My word.
But the best example I always have of this, which is a few years old now, was that the casino in Las Vegas that got hacked through the thermometer in its large aquarium. And it was such a clever and sophisticated attack. And the story behind it is, the people who were doing it, the team that were doing it, planned this over weeks and months. They did it properly. They sent one person in to look at the casino and check where all the CCTV cameras were and find the blind spot. The next person went into the blind spot. Obviously, there'd been no way of tracking it was part of the same team. And worked out how to access, the aquarium. Then the third one went in on another day, managed to get the device out. Now, a lot of these internet things, they're based on very small little circuit boards, very, very tiny. And the old ones, which were pretty stupid, if you pressed the reset button, it would blank the network details on that device. And then it would come back. But if you had your own device connected to it, it would give you all the Wi-Fi and security codes that device was using to connect to its network. So what then? They would take the information and go away again. Then somebody else would come in with the same information, not go near the aquarium, but use the same code to then use that IoT credentials to pretend to be a thermometer and log on to the network. And what they then did was they stole about 5 gigabytes of information for that casino's most high value customers. Now, isn't that just worthy of a Hollywood film? I mean, my God, that's just genius.
I'm going to say, I'm not quite sure where we're going with Ocean's Internet of Things. Doesn't have the same ring to it, does it? Really?
Yeah, Ocean's IPv4 or something like that, maybe.
So to network access control, that then becomes very important, because what you first want to do is you need to make sure that all devices have a little hard burned in kind of serial number called a MAC address. And so what often happens is that network access control systems will recognize what that MAC address code is to identify, has that device been changed, has it been swapped out for something else? So that's one layer of protection. And other ones that are a little bit more sophisticated will do AI anomaly detection. So, for example, if your classic thermometer in an aquarium hack, you might be able to spoof and pretend that your mini laptop has got the same MAC address as the thermometer.
I was going to say, you can spoof a MAC address. Yeah,
what
absolutely.
You do is you look for anomalous behavior. So if you've got a device and it will recognize its network, then what this device does is send like 1 kilobyte of data every 30 minutes. Except on Tuesday at 2 a.m., when it suddenly started exfiltrating 5 gigabytes of data, and the anomaly detection would go, that's not a thermometer. And they would shut down the port, because there's no point having network access control that, like the plumber, just measures it once. You need to measure it continuously. And if something changes, it shuts down the port. Or with Wi-Fi, it throws you off the Wi-Fi. So that's kind of it.
But the key element here, more than anything else, is the fact that also when you're introducing these Internet of Things devices, you don't want to put them within your standard network in general. They need to be on a different subnet. They won't. Maybe all they need in their life is access to the internet and nothing else.
So when I said earlier about the special,
you put them in a subnet
where
that only
it has access to nothing else. That's a very typical protection for an IoT network. Like you say, its own discrete network, and also IoT devices can speak to nothing except the next generation inspection firewall that will just, first of all, keep it away from all other IoT devices, and also will do anomaly detection if it starts behaving oddly.
I mean, I suppose it's also maybe interesting the fact that, do many businesses know how many Internet of Things devices they have on their network? Because I can imagine it's one of those things whereby you buy a new piece of technology. Let's say, for example, I don't know, you buy a lathe because of the fact that you're doing stuff with metalwork or woodwork. But nowadays, I would wager that lathes come with large computers and software allocated to them, but they might have additional components that then also run independently. Maybe they're more Internet of Things devices. But they need to be able to intercommunicate. So I would wager that all the businesses do is just go, we put them on the network then. So they put them on the network. But the point really, what we're saying is the fact that no, you need to try and make sure that you isolate those and you only give them access to the elements that they actually need. So it's the access control element of NAC that we're very much interested in, because we don't want global access.
Some of the most sophisticated firewalls will scan a network, and what they will do is they will have a database of. I keep talking about MAC addresses. They will have a database of MAC addresses, and because these addresses are burned in at the manufacturer level, it's not something you can configure yourself. They will be able to say, I recognize that MAC address. It is such and such a device. They will know what model of Internet of Things device it is. They will know the chipset. They'll know the behavior. So if you've got thousands of these devices in your factory, that's a lot of management overhead to go around and individually configure it. So what you rely on then is these databases and these clever firewalls that will automatically recognize the MAC address, assign that thing to a network, and manage its connectivity and do the anomaly detection as well, all automatically. Yeah, and that's really where the world's got to go, because as you say, if factories were as sophisticated as Christian's house, I mean, there would just be gazillions of IoT devices, wouldn't there?
I'm very interested to know how many DNS entries he has currently on his network. That sort of stuff. So, no, we're not going to find that out. Okay, disappointing.
Company secret.
Disappointing.
Company secret.
But I suppose the other thing we talked earlier on about sort of zero-day attacks, so the fact that software is being attacked on a regular basis and vulnerabilities are being found in software, in fact, especially quite old software and functions and routines, etc. And Internet of Things devices are by no means exempt from that. If anything, they're probably slightly more exposed to that sort of thing.
Because they're stupid.
Because the Internet of Things device companies don't make computers, do they? They make cookers, fridges, even cars. We've had instances in the fact that where car manufacturers have built in locking systems into their cars that actually were really exposed, and people have been able to go on the internet and just unlock other people's cars at random because of the fact that they'd not locked them down at all. It's going to be an issue, isn't it? I think
absolutely. As I said, because as I say, they are stupid things, and they are a real hack target, for clever attackers, because they make, we're telling you what's the best practice around isolation and anomaly detection, but for a lot of businesses who don't have the time or the knowledge to do that, as you say, they'll just put them on the corporate network, and just as something that can be, especially on Wi-Fi, they're not that difficult to hack.
Yeah, and we all know from a point of view, an IT perspective, the manufacturing department comes up with a new device that they've just bought. They want to get it in and working. They've got an engineer coming on this day, and the networking guys haven't got time to build another network subnet by the time they arrive. So it goes on the main network, doesn't it? That's just the way life is in business quite often. So I think, it's a point of security. It's an issue for security, no doubt.
Definitely.
Yeah, that's the point, that those information has to come in early during the purchasing process, because also in production, it's not that they shop their large manufacturing machines with one big online retailer. It's a week-long process for them to get everything, if it's not even more. And normally there is enough time to include IT or IT security into that process. But the business has to understand that this is necessary, and this might be the insurance that your business is still running when you put in new things. So really try to get in that process and make the business understand it's important.
All right, just curious, are there any other horror stories that anybody knows of with regard to Internet of Things? Because it'd be nice to have another one as well if there is one.
There are many, but they are slightly different.
Okay.
What I fear with cloud connected things, Internet of Things, is that the vendor just shuts down the cloud service and your little thing is getting even dumber because you can use it anymore. That's happening a lot in the last time, where some vendors only support their stuff for like 4 years, maybe 5 years, and you don't want to change your thermostat every 5 years. So that, in my opinion, is also a horror story that is going on there. If you are trying to find something that you want to put in your home or in your company, make sure you get a vendor which at least has some kind of track record of supporting things longer than three years.
That's valid, actually, isn't it? Because generally speaking, people tend to buy things on price and on features. Exactly. And often you can buy cheap and featureful devices.
Exactly.
But like you say, maybe no longevity on that basis. So yeah.
And then you have stupid things. Maybe they are still running, but they will never get patched again. Or that they just invalidate the value and the function of it.
Yeah. That's really
no, but that's even Google did that, by the way.
Oh, okay.
Yeah.
I think I got a refund on one of my Google products because they decided to shut it down. But yes, cool. So summing up, I suppose. So NAC and the Internet of Things, Damien, manga cartoon, or really important to have those two things combined?
I think increasingly important.
Absolutely, and I think, and is NAC? I suppose the immediate question is NAC expensive? I think thoughts on that?
The main problem with NAC is the amount of time it can take to manage it. I mean, there are classic kind of things that a lot of companies use. That Cisco do one called ICE. I see Aruba have ClearPass, which is again another one. There are others as well. Juniper have just brought a very new technology themselves called Access Assurance, which I think is getting a lot of interest simply because it hugely simplifies the management. Because it's the management of the thing that takes the time. Total cost of ownership. It's not just how much money the boxes cost. It's how much time the members of staff are going to take to fix it.
Yeah, good point. Great, Christian. Any thoughts? Final thoughts on NAC and the Internet of Things?
Do it.
Yes.
At least do NAC. Really think about it. And as Damien said, there are ways now to handle it. If you have your IT operations running in a good way, then I think it's a good thing that can be implemented to your process. It's pretty easy.
Yep.
Getting it up and running, especially in production areas, is time-consuming and nerve-wracking process. I can tell you that, but it's worth it.
Good. Okay, cool. And I suppose from my perspective, I would say that you have more Internet of Things than you think you have, because I think most businesses tend to say, "Oh, we don't do Internet of Things," because they think of Internet of Things as being devices that they have that they sell maybe as part of their products. But actually, I would wager that most businesses, if they looked at how many things are sitting on their networks, just like Christian, there would be masses of them just talking to the internet and getting updates and everything else on those lines. So yes, and they are vulnerable by definition because they're not computers. They're very, I'm not going to say thick because I think we're shaming them, to be honest. We should be shaming Internet of Things devices. But yeah, they are unintelligent devices, let's go with. But yeah, I think it's something that everybody needs to think about when it comes to putting stuff on their network. Great, guys. Thank you very much for the chat. And thanks, Damien, for joining in for us on these. It's been great having you.
Really enjoyed it. Thank you for the invite.